Okay, let's start our conversation with the area of parallelograms and triangles and start off with parallelograms. Now, this is definitely a figure that you're accustomed to seeing since chapter 5 in the first semester, and it's just your plain parallelogram. Now, within a parallelogram, I could drop an altitude from D to side AB, and it would create within the interior of the parallelogram two shapes. On the left, I'd have a triangle. It'd be, in fact, be a right triangle since it's created by an altitude. And on the other side, it would be a trapezoid. Well, if I ignore the parallelogram for a minute and move this area of the right triangle to the other end, you'll see that my parallelogram has become a rectangle. Now, I haven't lost any area, so if I can quantify this area here, I'll have the formula for the area of a parallelogram. And recognizing that this is a base and this perpendicular height should serve as a height for the parallelogram, that gives me my formula. So just like a rectangle, the area of a parallelogram is area equals base times height. Okay, now let's take a look at a triangle. To do that, I'm going to bring back the parallelogram and look at the formula. The area is base times height. Well, if I draw the diagonal, and any diagonal the parallelogram will do, I see that I've divided this parallelogram into two triangles. Now, if I were to get rid of AD and CD, you'll see that I have half of the parallelogram. Therefore, the area of a triangle is just half of the area of a parallelogram. So instead of base times height, the area of a triangle is 1/2 base times height. Okay, Ramblers, before moving on, please make sure that these two formulas are in your notes. So now we have two formulas to add to the two we already have. So we have area of a square, area of a rectangle, area of a parallelogram, which is also a rectangle, and a rectangle is also a parallelogram, and we have the area of a triangle. I know this seems really primary right now, but I promise you the stuff is going to get more complicated and you want to have it organized. Okay, thanks for watching. Okay, Ramblers, in chapter 11 we've had two videos now, and in the first we talked about the basic unit of area, which we've said is the area of a rectangle. That, of course, was just equal to base times height. Then we looked at the area of a square, because a square is a special rectangle where the base and the height are the same, so that area formula was just s squared, or the side squared. Well, in this video, we wanted to broaden the definition of rectangle to include all of parallelograms, and that, as we saw from a simple cut and paste procedure, the area of a parallelogram really can be interpreted as a rectangle with one corner of it moved to the other side, and so that area was also base times height. Finally, we recognized that any parallelogram can be cut in half along its diagonal to form a triangle, or two triangles. So the area of one triangle would just be 1/2 the area of a parallelogram, which gives us the area formula for a triangle. Ramblers, we're going to have a lot of formulas in this chapter, and then next chapter is going to build on them. So let's make sure you have these four in your notes, and we'll move on from there in future videos. Thanks for watching, and I hope this helps. Number 18 on page 521 points out one of the tricks that comes up in this chapter, and it's really useful to learn, and maybe it's a little hard to see. So let's go through it. They give us this triangle, PQR, and they tell us that QT, the altitude drawn from Q, is 12, PR is 15, so that's the side that QT is drawn to, and PS, the other altitude, is 10. And they would like us to find the area of the triangle and the side RQ. If I redraw the triangle, I can see that I'm going to use 15 as my base, even though it's not in the bottom, and 12 as my height, even though it's not drawn vertically. Because I'm looking for the area of PRQ. It doesn't matter which side is my base or which side is my altitude. All I need is a side that is perpendicular to an altitude, and certainly PR and TQ will do. So my area is going to be 1/2 12 times 15, which equals 90. But in part B, they ask us for they ask us for something else. They want side RQ. And they give us another altitude, PS, which they tell us is 10. So now I'm going to use RQ as my base, and PS is going to be my altitude. And so I will import my answer from part A and set up another area equation. This time I know the area, so that's 90, and that equals 1/2 the base, which I don't know, that's RQ, times the height, which they tell me in the givens is 10. So when I work all this out, I get that RQ equals 18. It's a really important problem to recognize that we can use area to find parts of the triangle or the different figures we're going to work with. Okay, let's take a look at number 17, which is another really common theme throughout this chapter. Number 17 on page 521 presents another common theme, and that is finding the area of a figure indirectly. So I don't know a formula for the shaded triangle. I don't have a altitude and I don't have a base for this triangle. So what I'm going to do is take a different approach. Okay, so I'm going to break the large triangle up into sections. We have the shaded section. We have what I've called triangle A, triangle B, and the rectangle. If I subtract the area of triangle A, triangle B, and the rectangle from the large triangle, all that's left is the shaded. So that's what I'll do. The area of the large triangle is 1/2 the height, which is 13, times the base, which is 18, minus the area of triangle A is going to be 1/2 the height, which is 8, times the base, which is 6, minus area B is going to be 1/2 the height of 5, times the base of 12, and then finally the rectangle is 5 times 6. So if I figure all that out, I get an area of 117 for the large triangle, 24 for triangle A, 30 for triangle B, and 30 for the rectangle, giving me a shaded region of 33 units. Okay, Ramblers, thanks for watching.